record and refresh what we have looked at last time, and that was section 4 of chapter 1 that deals with circles. So the key idea was that we developed the equation of a circle, x minus h squared added with y minus k squared, and this is equal to a square of radius, r squared. And that was a formula for the circle, and the circle had two things that we needed to graph it. Center, the point to start with, and we call it with a pair h comma k, center of the circle, and radius that is automatically called as letter r. Center and the radius enable us to graph that circle on xy plane, and that was the idea for the exercises. And of course, I was trying to get this worked out a couple of times, and today I plan to do another exercise here. So we usually look at the skill building exercises. Unless you prefer something else, you can always tell me if you are interested in some other exercise. And I guess the idea of this section 1.4 from perspective of preparation for what we need is to do problems that deal with completing the squares procedure. So I can select one exercise and we can refresh of what we did last time. So maybe something pretty standard, like not sure if I did 29 or 30, something like that, because I don't want to do the same thing again. Maybe I can try one with 3, number 3 for a change. Maybe like exercise number 34, the last one in this group. So we need to write equation the way the goal above looks like. So here we have 3x squared and 3y squared and minus 12 times y, which is equal to 0. So our goal is to make sure that we have x term with square and y term with a square. So we have those on the left side, but number 3 is on the way, so I will divide by 3, so this way we'll just get clean x and clean y. So this way we're gonna get the x squared only plus y squared only, and that's just what we needed. And also negative 4 times y will be next to it. And this is equal to 0, so I give it a little room so I can take care of that negative 4y's, which is on the way. And to do this, we used to divide by 2. So we used to divide by 2, and when I divide 2 by 2, I get number 4. Right, so I add that, 2 divided by 2, 4 divided by 2 is actually number 2. That I square, and then I also add this 2 squared, which is 4, and also subtract the same number 4. So it's technical, and I guess our goal is to...
Excuse me, sir. Why did you square it for number 2? Like for +2, why did you put a square?
Well, because when I complete the square, I'm gonna have y here. instead of y squared, the first term, and then 2 squared will give me just a 2, and the minus is here. So goal is to produce a perfect square, to write something in the parentheses squared, and the reason why is visible when you start to multiply this twice with itself, because it's power of 2. So you can see that when you square, you multiply in the first terms y by y, you get y squared, and then you multiply -2 with a -2, and that's how you get a +2 squared. So y squared, well, because I have to have the same parentheses multiplied, so last terms will be squared. So that's why. But the goal is not to, I guess, see it that clearly, but just to get used to the process. So, and in the middle, of course, there'll be inside and the outside product, there'll be twice of them because they're same, they're both 2y's with negative signs, so it'll be twice 2y, so that's our -4y. So I pulled out that 2 by dividing it by 2, that 4. So we had back our 4, which is twice. So it's kind of repeating this idea. But anyways, in every single exercise, of course, it's good to realize that what's happening, but in every single exercise, we just follow this little process. And now I can see what my center and what the radius of the circle are equal to. So we actually subtract nothing from x, so it'll be 0 that I subtract from x, and 2 I subtract from y, so it'll be 2. And the radius is 2 squared. I can treat as 4, so it'll be 2, because radius squared is on the right side. So you could just rewrite this with x minus 0. That's you don't have to, but just saying that 0 is x coordinate of the center, and the 2 is its y coordinate, and the right side supposed to be a square of radius, so radius is 2 squared. So that's what we did, and I selected a simpler type of exercise. I think if you can do that one, then you can tackle the others. And that's what we're actually going to do in the next chapter that I want to move on to today. In fact, right now. So I'd like to go back to the contents. You can see how quickly to get there. So if I, no, it's chapter review. So if I go to the beginning of section, so I highlight this, whatever 2-1, whatever section is, and click on it. So the book brings me back to the contents. And now we finally gonna start with the material for our class. Again, that will heavily use completing squares, but maybe not today, maybe on Monday. So in chapter 10, they start to work with your old friend parabola. And the first section of chapter 10 actually gives a interesting geometric introduction of how these so-called second degree curves being produced from sections of cone. So we have here a cone, and we can cut it with either plane that is parallel to its base. So when you cut it, it'd be a circle, and that's what we just looked at, the circle. Maybe I can try to make it a little bit bigger, try to magnify it. So circle you produce when that plane is parallel to the base, and if you make a slant plane, turns out the result will be a so-called ellipse. Ellipse is a circle, but like a football, if you say step on it, say on the top, then it's gonna squeeze a little bit and give you not a circular shape, but people call it as elliptic shape, ellipse. And turns out if you keep moving this plane that you cut it with in such a way that the side of the cone will be parallel to this plane, so you can kind of imagine it be parallel, then the cut will be your old friend parabola. It's kind of interesting to know. And if you keep moving it, so the plane is not going to be parallel to the side of the cone, but it'll start to intersect it. So there'll be two branches of the cut on the top and the bottom, and that will be called as hyperbola. Well, I don't know why they put this in here. I think it's nice geometric interpretation, but there are no exercises in here. But they're just trying to give you an idea that whenever you have square in your formula, like here we have x squared, then you're going to have one of these four possibilities. Either it'll be circle, that's the one we worked with. And the next thing, we're going to start with our old friend parabola. And then next time, we're going to look at the last two things, such as ellipse and hyperbola. And you already learned the way parabolas looked like. The favorite parabola was y is equal to x squared, right? So the one that opens up and has its so-called vertex at point 0, 0. And here they just refreshing your memories on this. If you say forgot, it's not a big deal. You can actually see how those graphs are being produced. And the other graph that we also talk about in the college algebra class is parabola that opens to the right, where you switch your x and y, so you get equation x is equal to y squared. So this is how they think of parabola, but rotated by 90 degrees. So when you switch x and y, you don't switch your axis, you need to switch your graph. So instead of opening along y-axis, now parabola opens along positive direction of x-axis. And that's what they're working on here. And they also bring a little extra piece of information, the one that I don't think I want to go over, but just to mention briefly, that turns out that if you have a special point called focus somewhere on the x-axis, and if you put a light, like a flashlight, then the light beam could simply reflect through the parabola if it's made from glass, from the like mirror surface. And all these light beams are going to go parallel with each other. So this way you get a very good flashlight. And that's used in, say, police flashlights, because they have very good surface in terms of parabola, and it's mirror-like, so it reflects on one side of this mirror and goes parallel, so all these light beams will go parallel with each other, and that way it'd be a very strong result. So you're gonna see pretty well and pretty far, and well, I guess that's a remarkable property of parabola, but the reason we talk about it is this key point called focus, and that's what they're saying. So if you have a way to find the focus, if you treat this as a y squared is equal to, they say, 4a times x, like in this formula, so they don't really prove it, but they just state it. So your given actually example that I just made up, the old favorite parabola that opens to the right, y is equal to y squared is equal to x, you could also write in the same form, so just you, instead of 4a, going to use number 1, that will enable you to locate position of that focus. And that's something we never did before in the college algebra class. And I guess we're never going to do it again. It's just in relationship to the start of this chapter. So it turns out that 0.14 is where you should put this source of light. So that's how they come up with this word focus. And we're gonna use this word focus again in the next chapters, in the next sections. That's why I just wanna briefly touch it. And that's pretty much all I wanted to discuss here. So we're gonna do some exercises to refresh your memories on how you worked with these parabolas. So let me try one here. So section 10.2 is what we're looking at today. I wanna clean this mess before we move on. And actually looks like we'll be able to complete another square here. So let me recall how the parabola used to look like in general. So there was also a pair HK, but we utilized it for the vertex. If you remember, standard shape for parabola was like a y is equal to x minus h squared plus k. And of course, there was a possible number here in front, but I'm not gonna bother with it right now. So I'm gonna just try to relate it with what we already saw today. So if you put k on the other side, and there'll be x minus h squared, then this is still parabola with that key point vertex, right? Where h, what we subtract from x is always h, and from y we'll always subtract letter k. So the vertex hk, and if you have it, then you can right away produce the graph of parabola. So, for example, an exercise like 41, if I have y minus 2 in the parentheses squared, and this is equal to 8 times x plus 1, then I can utilize the idea of a vertex of parabola, which is going to be a pair with coordinates for x is what we subtract from the x variable, and that'd be -1, because we'll always change signs, right, in the parentheses. And for y coordinate will be +2. So we have here parabola with a vertex at -1 and +2, the vertex. And then this parabola is not in the shape of y is equal to, but it could be treated as if it was in the shape of x is equal to. In other words, this parabola will open to the right, just like we had in the example here with x on one side. And of course, one may question, say, Alex, how come this is really opening to the right? Well, you can distribute number 8 here. So you're going to have this y minus 2 in the parentheses squared is equal to 8x plus 8. So that's what we did before. And then we would isolate our unknown x. So 8x is equal to this y minus 2 to the second power. And it's -8. So we used to always isolate our unknown y. So here, if I decide to isolate x, I need to divide by that 8 each side or each term of our equation. And this will bring us to this 1/8 multiplied by y minus 2 squared, y minus. Y minus 2 squared and minus 1. Let's see, so what, we did not seem to graph those things much. Yes, but we graphed their analogous curves with y on one side and the shape where we had y is equal to something. So if I had y in the place of x and x in the place of y, so if I can put 1/8 times, instead of y, I put x minus 2 squared, and then subtract 1, then right away we could say, okay, vertex here is with coordinate -1 for y and a +2 for x, so it'll be 2 and -1, something like that. And this parabola is pretty wide because it's 1/8 that is multiplied by it, so it opens along y-axis. Of course, it's symmetric. But since we're switching x with y, then this parabola, instead of positive direction of y-axis, will go along positive direction of x-axis. And instead of vertex at 2, -1, we switch this and produce -1 and a 2. So using analogy basically is what we can imagine the way the graph looks like. So that's something that we saw, but kind of did not really concentrate much on. I believe chapter 3 was work with parabolas. And the good thing is you have the textbook and it's all in it, so you can always check it out. And if you feel like it, I believe it's section 3.3, and you can look at how we graphed those parabolas. And as I said, the goal was to complete the square for you again, because we've been doing it for a while, and I promise that we'll see it again and again. And in exercise 47, we'll do it again. I just need some room here. So in exercise 47, they gave us parabola. Well, they actually say that this is parabola, but you can see that indeed it is parabola because it has a square term. In exercise 47, it has y squared, but x is without square. So it'd be y squared minus 4y. And then plus 4x and plus 4. So maybe I'll put this away. Plus 4x and plus 4 is equal to 0. And whenever I have y squared and y, so the term with y is always going to bother me, because my goal is not to have that y term, but to, well, do the same thing we already did today. The half of 4, which is 2, and I'm going to add it as a 2 squared and then subtract as a 2 squared. So these first 3 terms will be converted into perfect square, and that's the goal. So this perfect square of y and that number 2. And there is a minus. And actually, this is not a minus 2 squared, it's actually the number -4, so it cancels nicely with a +4. Oh, so that's not bad. So now what? I also have -4x, so I can bring this over to the other side, right? -4x. And then I can also pull out my letter x by dividing on both sides by -4. So we will always pull out one of the unknowns, whichever one we can. Looks like since x will be here on the right side, then our parabola will be opening to the left or to the right rather than up and down, right? So So our simplified form will be x on one side, and then I can put -1/4 in front of this y minus 2 squared. And again, use an analogy to graph. If I switched, put y on one side and then -1/4 times x minus 2 in the parentheses on the other side, I hope you will recall right away that this is a parabola that has a -2 in the parentheses, so it's shifted 2 units to the right. In other words, its vertex will be a 0.2 and a 0 because we don't subtract anything from y, so it'd be right here. And then it will open down because of this negative, right? And it's multiplied by 1/4, so it's expanded a little bit, so it's a little bit wider somehow. So once I graphed the one we more familiar with, I can analogously do the same thing with the actual exercise 47. So y minus 2 means I need to put 2 but on the y-axis, because instead of having vertex at 2, 0, now we have switched them, so it'll be 0, 2. 0, 2, and on the y-axis. And then parabola, instead of going down, is going to go to the negative direction of my y-axis, so it'll be going somehow like that. And it's also a little bit wider. So the idea is that utilizing analogy, we can produce a graph of parabola. Well, the goal for this section is not going to be really that much into parabolas of this chapter. It's about something that we're going to see next time. What's going on? I get trying to magnify, it doesn't get magnified. And just kind of wondering why not. Just clicking on that plus, it should be a bigger picture, but somehow it's not going. Maybe it's got corrupted. But I guess it's okay. So what I want to do is try. I was actually thinking about giving you a little quiz. So I want to make sure that this is bigger. So let me find this textbook again, and then we'll give you a quiz because I think it's got corrupted. So let me do the following. I'm going to type again. So it's Sylvan. See, I've been typing it before, so it's already here. Pre-calculus and PDF, so I click on that. And the first choice, that's how we find the textbook. So now after it opens, I'm going to go to, oh, it opens right where we are. Oh, that's convenient. Nice. So let me see if it's going to, okay, so now it zooms. So now you can see better. Let me zoom it again so you can better see it. Okay, so let me do one exercise for you, and then I will ask you to do another exercise. And what I will ask you to do is to find the graph of parabola. So I will ask you for a quiz to do part A of the exercise. And what I'll do for you is part C right now, which is going to be pretty much the same thing. So I hope that's what you're going to feel comfortable with. So part C, what they want. Well, here's the parabola. They write it as y squared is equal to -4x, or you could just divide by -4 on both sides and have x is equal to -1/4 times y squared, right? So this is something similar to the graph that I already know pretty well, which is the graph of y is equal to -1/4 times x squared negative. So I missed minus, you should be careful not to hurry. So if I switch x and y for convenience, -1/4 times x squared will be parabola that opens down, right? And a little bit wider, something like that. But that's not what they asked. What they asked is to switch X with Y. In other words, this graph is going to also have same vertex, but now it's going to go not downwards, but along negative direction of my x-axis. So it used to go along negative direction of y-axis, right? Open down, in other words. But here, instead of going negative direction down, it goes along x-axis negative direction. So it's going to the left. And then what I can do is look for this graph here among 8 choices provided. And it looks like choice is number 17. So for the quiz, all you need is to tell me 17 is the answer. But the quiz will be not this one, because I already done it, but part A. It says, find the graph of x squared, which is equal to 4 times, oh, sorry, it's y squared. Should be. So I rolled it such a way I can't see it. So y squared is equal to x. Nice. So y squared is equal to 4x, which is going to be pretty much same thing, but you can see there is no minus sign here. It's probably going the opposite direction. So the question is, find the match of the graph. You definitely can't. Oh, you actually given the graph. So now the question, actually, no, you give an equation, part A, just like I did in the part C. You have equation. So equation is, what's the matching graph? Is this going to be 11 or 12 or 13 or 17? Actually, 17 is already gone, so it should be one of the remaining. So how can you do the quiz? So please use the chat, Zoom chat. And that's where I usually put messages for you. So you click on that blue-red bar, and about in the middle, a little bit to the left, you will see word chat. So once you find the matching number, please send it only to my name. Don't send it to the whole class. I say, what's going to happen if I send it to the whole class? Well, nothing's going to happen, but if it's a wrong answer, others not going to be very happy. So don't hurry. Don't rush. So just select only Alex, only my name, and put whatever number you think it is, 11 or 12 or whatever you think is in this chat. And after that, enjoy your weekend, because it's Friday, so have a great weekend. So you can locate that matching number to the, again, equation here, whatever the graph you think corresponds to it, and put this in the chat. If you have no idea what it is and don't feel like thinking, you don't have to. You can send it to me later. I'm checking my email, so you can send it to me tonight or tomorrow, so whenever. And that's actually same to people that are not present here on Zoom. That's okay. I already told. That's not a problem. You can watch this question when I send you this recording, right, in a couple of hours or so. So they can watch the recording and do this quiz at their convenience and email me the answer whenever they ready. So point is, I don't want to push you to give me the answer right now. If you're not sure, you want to think more, think, take your time. Math is not about the rush. Math is about doing it right. So don't hurry, okay? Take your time. And that'd be all we need for today. So have a great weekend. Relax. First week is always overwhelming, right? So when you put the answer in the chat, you can log out and have a great day. Okay. Thank you. And thank you for coming.
Thank you, Professor.
Thank you. Thank you. Bye-bye.
All right. Thank you, Professor. Have a good day.
Thank you,
Yeah.
Professor. Have a good day.
Have
Bye
a great
bye.
day.
Thank you.
Bye-bye. Have a great
Bye. Thank you.
Bye.
Have a great day.
Thank you. Bye. So don't hurry. Don't hurry. It's no rush. So again, on the quiz, we do problem A, which is the one here on the top of the page, skill building exercises. It says match the graph with this equation. So this equation is given, and there are 8 graphs down below. So which one you think corresponds to this equation? And after you're done, you can just log out and have a great rest of the Friday. Okay. And I just did similar exercise. I just did number C, and so it's corresponding to number 17. So all I need is just the number. So just put the number, and that'd be the answer for your quiz. Because you can't graph, you just can find the graph and see if this is the one that corresponds to this equation.